Gemini Robotics-ER 1.5 is a thinking vision language model optimized for embodied reasoning. This means the model doesn't just think, but can also act in the physical world. It is now in preview and available through Google AI Studio and Gemini API for developers. This video will show you how to use the embodied reasoning model through the Gemini API to build your first vision AI app, capable of displaying 2D points in an image and labeling the objects within it. Let's get started by trying Gemini Robotics-ER 1.5 in Google AI Studio. To try this example in Google AI Studio, you will find a link in the description of the video. Over here, you have noticed I have already added an image. To add a new image or file, you click the plus button and select the option Upload File. On the top right of the browser, you have noticed the model selected is Gemini Robotics-ER 1.5 Preview. As I mentioned previously, the model is now in preview mode in both Google AI Studio and through the Gemini API. Over here, we can customize the model's configurations like temperature. However, we want to use the default settings. So let's add this prompt. We want to identify and label up all the objects in the video. So we want the model to point to 10 objects in this image and also label them. So let's run the prompt. You have noticed here we have a response from the model, and these are all the identified objects. Let's also add a follow-up prompt to display the output in JSON format. We now have a JSON array containing the image objects, with each point and a label identifying it. When you use the model through the API, you will also get the output in a JSON format. So in some point of the video, we will take the JSON output and create a Streamlit app to display the point and labels directly on the image. You may be thinking, what are the use cases of this model? You can use the model for many use cases because it goes beyond building a chatbot and can be used as a high-level reasoning model for physical robotic projects. It has visual and spatial understanding, that is, its ability to understand the physical world. This makes the model suitable for task planning. You can also use it for object detection and tracking in images and video, similar to Ultralytics, which help developers to turn images and videos into valuable AI insights. Or Moondream AI, a visual AI platform for image captioning, gaze, and object detection. There is also another platform in this AI space called RoboFlow. This is an AI platform for building computer vision apps to detect objects in images and videos. You can use the RoboFlow platform to track the motion or movement of video objects and also use it purposely for counting. RoboFlow is an excellent platform for video analysis. Let's also look at the key capabilities of Gemini Robotics-ER 1.5. The model supports multimodal input, so you can use speech, text, and images as input, or just combine them. It supports tool use, so you can call Google Search to find information and also call a vision language action model or custom functions to execute tasks. For robotic projects, you can use the model for sorting out objects into correct forms or use it for cleaning up a table. It supports object detection and tracking, like the RoboFlow examples I showed previously. You can use it for 2D point generation in images, like the example we show in Google AI Studio. So you give an image of a scene, and the model can provide the location of every object within the image. To prevent hallucination, you should be specific with your prompt and also ask the model to include only a certain number of items in the image. Like the example I showed in AI Studio, I asked the model not to display more than 10 objects in the image. So the example we want to experiment through the API illustrates an everyday use case. It demonstrates how to pass an image and a text prompt to the model using the generate content method to obtain a list of identified objects along with the corresponding 2D points. So the model will return all the points for the items it will identify, along with their normalized 2D coordinates and labels. To get started with Gemini Robotics-ER 1.5 through the API, you can use your favorite editor and set up your Python environment. In this example, we are going to use Cursor. If you don't want to use Python, you can access the model through the REST API. First, you should set up a virtual environment in Python and activate it with these commands. Next, you should get a Gemini API key and export it with this command. If you don't want the export option, you can create a new .env file and add your Gemini API key. The next thing to do is to install core dependencies. You should install the Google Gen AI Python SDK with this command. After getting the JSON output from the model, we will need a UI to display the labels and points directly on the image. So we need a UI framework. For this example, we want to use Streamlit. So over here, you install Pillow and Streamlit. Pillow is image processing library and Streamlit will provide the UI. To follow along the tutorial smoothly, I have added all these commands in the description of the video. In my Kesa project, I have added this file, Gemini Robotics-ER 1.5. When I go to the Files and Folders Explorer, I have also added an env file to store my Gemini API key. So let's add the following imports. So these consist of the required libraries. We add the Gen AI SDK for interacting with the model and Pillow for image processing. Next, let's add the module to use and also define the prompt we want to use. For the prompt, we want to ask the model to identify up to 10 objects in the image, returning their normalized coordinates and labels in a specific JSON format. Next, we should initialize the Gen AI client to communicate with the model. Then we do image loading and processing. So we want to load the input image, my image. If I go to the Files and Folders Explorer, you have noticed here, I have the image. That is my image. This is a larger image. So over here, we load the image and also resize it to this format. We want the maximum width of the image to be 800 pixels and also keep the aspect ratio. Next, we will use this code snippet to send the prompt and image to the model for content generation. Over here, you can configure parameters like temperature and the model's thinking budget. Finally, we will print the response in JSON format, containing the detected image objects and their labels. So this is everything we need to do to get started with Gemini Robotics-ER 1.5 preview through the Gemini API. You will find a link to the source code in the description of the video. Let's bring the integrated terminal in Kesa with control and backtick and run the app. I will use Python 3 followed by the file name. You have noticed the output is a JSON array containing the image objects and each with the point and its label. For an advanced use case, you can use this JSON output with a robotic API and call a vision language action model or call any custom function to generate actions for a robotic project. As I told you previously, we want to take this output to display the point and labels directly on the image in a Streamlit app. So you come to the Streamlit website and go to the docs. Then you go to installation. You can install Streamlit with pip install Streamlit. I have already done that in the Kesa project. So let's do the implementation in this file, Gemini Vision AI.py. I'll clear the terminal and hide it. Let's add the following imports and also specify the model we want to use, Gemini Robotics-ER 1.5 preview. Over here, we have the prompt we used previously. Next, we will specify the page title and description of the Streamlit app. So we have the title and description. Next, we will add the following helper functions to get the client, load the image, extract the JSON payload, pass detections, and also annotate the image. So in summary, we pass and validate the model's response, convert the normalized coordinates to pixel positions, and also draw annotated points with label callouts directly on the image. The last thing to do is to add the Streamlit UI. So let's add this code snippet. With the Streamlit UI, we have a sidebar for model settings. Then we display the input image in the browser and also add an option to upload a new image or drag and drop one. Lastly, we also display the annotated image using the points and captions. You will also find a link to this sample code in the description of the video. I will bring the integrated terminal again with control and backtick and put the command streamlit run followed by the file name. So we have the output in the terminal, and if I scroll up, we have a link to view the app on the local host at port 8501. I will command click it to open it in the browser. So we have the input image. You can click this button to add a new image or file in these formats. You can set parameters like temperature and the model's thinking budget to improve performance and latency. And over here, we have the model we are using. If I scroll down a bit, we now have the annotated image. So we have the points and labels. The model displayed exactly 10 objects in the image, with the exception of those in the plastic bags. If I scroll down further, we also have the JSON output right within the Streamlit interface. This ends our tutorial in getting started with Gemini Robotics-ER 1.5 in Google AI Studio and also through the Gemini API. You can check all the links in the description of the video for advanced concepts like spatial temporal reasoning, a concept that involves understanding the relationship between objects in an image or video. You can launch Google AI Studio and begin experimenting with the model, and also read the Google Developer documentation for a comprehensive quick start. There is a link to Collab Notebook for practical implementations. There are also two model families, Gemini Robotics 1.5 and Gemini Robotics-ER 1.5. These two models can be combined to form an agentic framework. To learn more, you will find their tech report in the description of the video. Thanks for watching the video.